Cool. Okay, so today we're going to be talking about debugging Electron, but in a much more specific way than you have through the console. This is a low-level debugging that we used to figure out how our SQLite queries were blowing the memory out of the window. So first of all, the first step we needed to do was build Electron from source, which actually turns out to be fairly straightforward. If you take a look at the build instructions for Mac, really all you have to do is clone it, run script bootstrap, and run script build. And if you are in fact on the latest Mac and Xcode, this does in fact work. However, if you are not on the latest Mac and your Xcode versions is out of whack, sometimes you need to reinstall your entire operating system, reinstall all of Xcode, re-download everything again, and then it works. What that'll do is, so first of all, here, I made sure that we are on the correct tag. So here I had to switch head to here, so I built the correct version that we are using on our main app. Run script build, script bootstrap, script build, we've already done because it takes several minutes to do that. But then it drops into this out folder, just an Electron that you can use that's built from scratch. And all you need to do then is then pass that our folder. In this case, we're passing it just directly to the app here with dev and enable logging flags as well. Another thing to note here, I added this environment variable. So given the hunch it was in the database, this variable will actually output like all the raw log queries to the console. It turned out that if anything, was a little bit of a red herring because the problem was that the query never finished, not that it was like a query, like stashed in memory somewhere. So it never actually made it to the logging. But nonetheless, this is a good, useful thing to have. So the other piece that was required to set this up was that if you go into low-level debugging, you won't have any of the symbols for any of the node modules. And when we finally figured out it was SQLite, the other thing that we had to do was build it for build SQLite in debug mode. So a couple things below the hood here, right? So this is our app, and here we have our SQLite module here in our internal packages. Where am I? Hold on. There it is. So here's our SQLite 3 node module. The SQLite 3 node module, when it installs by default, puts I believe it puts it in build here. Right, so it builds the module against in our case, against the Electron headers and puts a running binary here. And the specifics of how it does that is that it has this package JSON down here. And at the bottom here, it has these scripts that actually run the install. This is just a regular NPM script here. Specifically, it uses this node pre-GeoIP, which uses node GeoIP, which is the build system that Google made. But at the end of the day, really all it does is that it takes a config. It's pretty much like make, and it builds it. And all we needed to do was pass it the debug flag. So I actually, when you normally install this regularly, this debug flag is not here. So I actually manually went into this file and added debug. And then all you need to do is you just need to rerun npm install again from the top level, and it'll go back through, and when it's doing the rebuild, it picks up the npm debug that debug flag, and it rebuilds it with that debug flag, and it sort of gets passed all the way down. There are other ways to do this too. The other thing that we tried was going inside of our own rebuild command and manually passing rebuild -- debug, which actually turns out to also work. The problem with doing this, however, is that it builds every single node module that we have with a debug version, which actually isn't awful. The problem is that they don't know how to deal with that properly. So for example, if you go for example, here's this nslog is one that has a built node module, and the lib nslog here hard code looks for the like compiled version inside of a release folder. And if you build it with debug flags, this gets changed into debug. So in a different version, I actually went into every single node module and manually changed that from release to debug, which is really annoying. Luckily, SQLite 3 is a smarter library, and it like doesn't use this hard-coded release debug crap, and it knows how to find the correct like folder when you build it with debug symbols. But this is also to show that building these modules is not particularly, it's actually not particularly fancy what the JavaScript does. It just attempts to require these built compiled versions that Node is figures out how to load for you. Another minor caveat with our Electron app here. So if I just ran plain old npm install SQLite 3, like again from scratch, right, that does not include, that compiles it against like Node's V8 headers, but we need to compile everything against Electron's headers. We deal with that. That's actually not too bad. All you really need to do is just pass it a shit ton of environment variables like that. But at the end of the day, like, it is just environment variables, right? These are just telling to use a different set of headers for a different compile target, and that will also install it correctly against Electron. Our regular npm install script will go in and it runs rebuild with those arguments for you, which is why just rerunning npm install with that package.json change works in this case. Okay, so that's the setup for this. Now let me show you it all actually working here. So first I'm going to boot up the app like normal here, except using our built Electron. Cool. And here's our worker window, blasting out all of our SQL because I have that enable debug flag too. This is actually how we were able to go back through and I could like search the logs and see if these if there's any weird IDs or any weird messages showing up. But in this case, it actually, like I said, it didn't even make it to the logs. So the other thing I need to do is I need to find the process of this window. It just so happens that the process of this window, the PID, is going to be the one with the most memory. Unfortunately, there's no great way to do this. I don't know if you can grab the process. You might be able to grab the PID from a Node API. But anyways, but for now, it's like process 23060. So I'm going to get that ready actually here.
Yeah, if you use htop, it should also list which window it is.
Okay.
Yeah. Activity monitor doesn't look at the process title.
Cool. So here to simulate some badness happening, I'm going to run this query that's going to try and grab all messages in a hard loop here, which should emulate this issue that we saw where like it was SQLite hanging everything. So the other interesting thing about SQLite is if you run a profiler here, if you do a JavaScript profile of this happening, you don't actually, it doesn't actually make it to the like profiler stack, right? Because it's running on a totally separate thread. It is not related necessarily to the like, it doesn't come from one of our main threads. It's a separate like node module running, which also made this particularly difficult because this is a rare type of thing that does not show up on either the profiler or the timeline, which sort of necessitated building all these extra symbols here. You will see it though. If you see a big gray splotch here, this just says other. That's a reasonable indication that it is like something else that's like outside of our main JavaScript code. And you'll see that in a second here. So let me kick this off. And you'll see that will very quickly blow the memory of that process out of whack. And let me catch that here. So this is lldb. And you pass this p flag to attach it to the particular process number directly. But now this has ground the entire process to a halt. And you can see it here. It's totally stopped here. It's totally stopped here, even though it kept spitting stuff out. Cool. So now we can actually see all of the threads and the processes that were there. If we do a thread backtrace all, This blew my mind. I never used lldb before Mark showed me the craziness that this is. So this is all of the threads that are running, right, on just that one process. And when CPU and memory say it's using stuff beyond the JavaScript heap, like this is actually the rest of the stuff that's going on here. This is renderer processes. This is like Chrome's background thing. This is Node going on. But the thing that we're looking for here is this. Where did it go? I saw it scroll past here. Here it is. Here's some SQLite. Cool. So here's our Node SQLite 3 on this thread here, running this process. And you can actually see already that it's, so first of all, you can see that we are successfully in debug mode because like these are resolving to actual like strings here, right? It's sort of, you can see the variable names, you can see the values as they're coming into the functions. Also for reference, this is the main JavaScript thread up here. libuv, oh, sorry, this is debugger. This UVQ, this is the, like, libuv is the one that handles the node event loop. And this is the actual JavaScript itself. This is the, like, interpreted JavaScript stack here. Everything in here you can get on the, like, regular Chrome inspector panel.
That's actually probably JITted code because it doesn't have any associated symbols.
Okay, yeah. Cool. So let's inspect this thread. 14. Cool. So here's the thread, and then we can go to the particular frame that we're interested in. SQLite 3 starts off just by looking through the source code. Mark discovered that this function here is sort of where it kicks off the, the queries in the stack. So we can back up to that frame. And here, because it's built with debug, you can actually see interactively the code that's here, and then sort of look at the code immediately around it as well. This statement handle is what we want to actually print. Oops. So Mark also found a built-in C function for SQLite that will take this pointer and basically spit out what the actual SQLite is supposed to be for that. And this is where our answer was. This is where we discovered that it was doing a like select all from messages where like this matched null, and it turns out that 80,000 messages match null. And it would never complete that because loading all of this out of disk into memory blew the memory of this thread and crashed the process without telling us anything in the meantime. Yeah. So that was one way to get down to this here for SQL. But it does mean that you can now inspect and stop pretty much any thread that's running beyond what you have in just the native Chrome profilers, which is a pretty cool set of power to have. And that process about rebuilding for debug flags works with, theoretically works with any node module. It was actually kind of convenient in this case that our backend used one SQLite library and the front end used a different SQLite library, so we were sort of able to tune that down a little bit there. This bug was also tricky because it, unlike this case here where I like manually fired it and we immediately saw it blow up, the other one was intermittent. So sitting there waiting, watching the memory usage until it was about to explode, and then quickly came in and tried to breakpoint lldb at the right time at that point too. Cool. And then we can quit this, but I kill this before it explodes. Cool. Yeah. Any other questions? Mark, do you want to add other? What else do you want to add?
So you can also get, we built a debug version of Electron here, and that's what we're using. But you can also build release versions of these various libraries. The version that we actually download and install by default doesn't have any function symbols. So you don't, if you were to posit in lldb, it would be able to give you the call stack, but it wouldn't know which functions it was in. And that's important if you want to profile. So if you want to be able to attach, for example, instruments and run a sampling profiler to see what's happening in C++ land inside of Electron or inside of a particular node module, you could recompile, and you would always want to do that in release mode, obviously, because debug mode is going to have a bunch of stuff that could mislead you in terms of like what's slow. So yeah, you could. That's another thing that you can do with this, aside from like attaching with lldb and looking at values and stuff on the stack. You can also run a profiler with these techniques.
So if I want to run the profiler, what should I compile with debug?
So when Evan originally ran the build.py script for Electron, it actually built both release and debug.
Oh, I see.
So there will be an R directory inside of the Electron build directory,
Gotcha.
And that will have the release build inside of it.
So if I want to profile, I want to use a release version of Electron.
Always, yeah. But the reason you build the release version is so that it has function symbols, because the one that's shipped has all those symbols stripped. So, gotcha.
Yep. Let me also actually show instruments real quick too. This was pretty cool. How do I choose the target?
Is Electron built with Clang or all platforms?
I do not know.
How is LLDB?
It's the version that's built by the LLDB folks, so it'll work better with Clang and stuff. But GDB should still be able to understand it. It just they have very similar feature sets, and the syntax is a little bit different for like issuing commands and stuff. But yeah, they're very similar.
Have you ever used LLDB?
Yeah, lldb is the one that's more well supported nowadays on Mac.
Yeah, because
Yeah. And they just use it internally. Like, like Apple people just use Clang and LLDB for everything. So it's very well tested on Mac.
Yeah. So let me also show instruments here too. This is just the instruments app that comes with your Mac debugger. And then all I had to do was find the correct process to attach it to here. Then we're also going to select the particular instruments that we want. So here is looking for activity. What else is a good one here? We're looking for like file access here, which is pretty interesting. The profiler. That's
You
not
can
good.
also look at like memory allocation stuff.
Yeah, where's the memory allocation one?
Like or something.
Allocations?
Yeah.
Cool. So then I can just run it.
You can also profile your entire computer, which is pretty cool. It's better to do it targeted if you know exactly what's wrong. But like if things are just going slow in general, or it's a hard thing to like catch, you can just profile your whole computer and zero that particular process.
So yeah, so this has pretty much similarly the types of stack traces that you used to from the Chrome Inspector, except it has everything else beyond just the whole node process into the just-in-time compiled JavaScript.
If you click, you see that gear icon on the right? Yeah. So now you can separate things by thread. So that shows you individual threads. You can do top functions, which is an interesting sort order where it like bubbles all of the top most expensive functions up next to each other.
Most commonly used? How does it define top?
Time spent.
Recursive time spent inside of it.
Yep.
You can also do the invert call tree, which puts the heaviest things on top. That's the heavy trace thing that you know from Chrome. So yeah, there's a bunch of different ways to kind of like try to figure out where we're spending a bunch of time in each one. You can also filter by symbol. So if you want to know how much time we're spending in like garbage collection, you would find that function, and then you can type that symbol in there, up in that little filter box. You might have to change it's searching for process right now. So if you click that little arrow next to it,
Yep.
and then do involve symbol, and then you can type stuff.
Yeah.
So yeah, those are just a few of the ways that you can kind of see
In the heap allocation one here, so this is a call stack of how threads are allocating memory as well. And then overall load over time for across the whole system. And there are a ton more things here. I believe you were using this before to look for like when we're having config issues, right? Hitting the file system. Or is that a different thing? Oh no, you injected a fuse. You were trying to build a whole fuse system in between.
Yeah, yeah. I mean, that worked. But it worked in the sense that the Python fuse thing worked, but like it didn't actually give us the information we wanted.
Cool.
Let's see, what else? If you have a release build of Electron, you can actually, you don't have to rebuild. If you catch something in the release build, you can attach an lldb and then you can disassemble the function that it's in, and then you can kind of tell what line of code it's on based on the assembly. You have to like cross-reference it with the original source code, but it's definitely doable. So I mean, if it's a really hard to reproduce bug in like some release build somewhere, then we can probably figure that out. You might need some like extra help, but yeah. Let's see what else.
What are some of the real world bugs that you guys have caught while using this?
Just the one.
Just
so
this
far.
one so far.
We've had a bunch of bugs like that where we've like run out of memory randomly.
Mm-hmm.
So I think that it's nice to have this particular process, so we know in the future like how to catch these more quickly.
Mm-hmm.
But yeah, I mean it's helpful for a wide variety of things. The profiling stuff is also really useful. I caught that rendering thing, that re-rendering width
Oh yeah.
thing.
Mm-hmm.
I caught that because I profiled it and then saw that it was doing layout a ton, and so that led me to look like, oh, what are we laying out? Oh, it's this little thing down in the bottom corner. So, yeah.
Cool.
Pretty awesome.